Hey guys,
Hi,
Shivesh, very nice, Shivesh. You made it the weekend very unforgettable. How are you, Shaurya?
I'm good.
Good. I know I did not post the packet last week, right? I'll do more this week. Shall we go ahead, guys, or shall we wait, or shall I remind others? Let me remind others. Oh, yeah, somebody's coming. Vidyut is coming. Who has to come? Oh, I think Karthik is forgetting. Okay.
Hi, Priyanti.
Vidyut, how are you, Vidyut?
I'm good. How are you?
Good. Okay. We'll go ahead.
Mm.
Okay, one second, guys. We'll do more of triangles today. Okay, if possible, I'll get into something else. Did we discuss incircle and circumcircle? No, meaning circumcircle and incircle, did we discuss? In radius and circumradius, did we discuss? No,
Wait,
right?
Priyanti, no. Is
Okay.
is the in center like the one that gets like it's inside the triangle?
Yeah.
Oh, okay. No, I
We'll do.
haven't.
Yeah, is the in radius inside the triangle correct? But okay, let's do that. You know, Shivesh, in radius, circumradius. No, no, I don't hear you. What is that?
No.
No, okay. Shaurya, how about you?
No, I don't know.
Okay, let's do that, right? Okay, we'll do the triangles. See, there's a ocean, I feel, okay? There's a lot of problem, meaning I really wanted to go to 3D geometry today, but I feel like there's a lot more to be covered in quadrilaterals and triangles itself, okay? So I'll do that. Next week, I'll maybe go to, see, since you guys really were interested in geometry, I go on continuing with geometry, but there's a lot more to go to probability, okay? Let's see. Whatever we can do, we'll do, okay? Let's see. What did I want to do? Let me start. I'm not going to do proofs in this class. Okay, I'll tell you the formulas we can do, and if you are really interested, you can go check out the proofs as well. Okay, so let's see this one. We'll continue with the triangles. Okay, we'll do similar triangles more, but wait. Okay, see whether you can do this. One second, guys. Okay, let's see whether you can do this one. Let me give you this. Let me see this. You are able to do this one. One second. Okay, how about this? Try this one. I can do it on the board otherwise. Sorry, guys. What happened? Did you get it? I don't know how to solve this. Let's do it together. Can we do it together?
I'm doing it right now.
Oh, okay, okay, okay. I'll wait. I didn't mean to hurry you at all, guys. Okay. Take your time.
10, 13, 13. Or no, sorry. 10. Hold on, starting. 31.
Shaurya, how are you getting used to Shaurya?
Huh?
You're getting used to?
Used to what?
No, no. Are you getting used to these problems?
Mm, kind of, but not this
Kind
one.
of. Okay. Not. That's okay.
Auntie, I sent my answer.
Yeah.
Yeah,
Wow. Good job, Vidyut.
I don't really know how to do this one.
No problem. You want to explain, Vidyut?
Okay,
We'll do
sure.
it slowly. We'll do it slowly. Yeah.
Okay, let me just get my pencil. So, uh, I know. Wait, I really don't know why. But I know the radius of the incenter is the area over the semi-perimeter.
Mm-hmm.
So then I just made this a full triangle. So like it's an actual full circle.
Oh, you use the in-center and semi-perimeter. Okay. Okay. Just explain what you did, right? Does not matter.
Okay. And then this is gonna be 10. Um and then it keeps deleting itself. Okay, this is 10. Oh,
Mm-hmm.
okay. And then because this is a 5, 12 triangle, this side needs to be
Okay, wait,
13.
wait, wait. Let's do it properly, Vidit. Okay, we'll go with you. Okay, let's see.
Okay.
This one is what did you put? AC is 12. Okay, this is 12. Then this is 5. Then angle C is a right angle. A semicircle is inscribed in the triangle as shown. What is the radius of the semi? Go ahead. Go ahead.
Oh. So then because this is a 5, 12 triangle and the hypotenuse has to be 13 because it's a
Good.
5, 12, 13 triplet. And then expanding the triangle to get the full circle, we have the entire perimeter uh, to be 5 plus 13 plus 13 and 10 plus 13 plus 13, which is
Mm-hmm.
36. And then we
Mm-hmm.
need the semi perimeter, which is 18. And then we find the area.
Oh, wow. Okay.
So
Okay.
12 times 10 over 2 is 60, which simplifies into 10 over 3. So that's the area, and that's the radius of the triangle.
So what formula did you use? Radius of the in radius will be equal to what? Let me explain that as well. Okay, before we move on. In radius will be equal to what did you use?
The area over semi perimeter.
Radius times semi perimeter. R perimeter. This is hard, guys. Okay, equal to the area of the circle. Okay, now let's first discuss this. Okay, what is this in radius? Okay, honestly, I don't think you need to use semi-perimeter and stuff. Okay, there are other ways to do this problem as well, is what I feel. I need to check. Hmm. Hmm. 1 second, guys. Let me see. AB. Hmm. Let me check. Is there any way to do this? Yeah, there is another way to do this as well. Okay, let's first discuss his way. Okay, I really liked your way. Vidyut. Okay, it's nice to think in different ways. Okay, first of all, guys, when there is a circle that's inscribed in a triangle, what is inscribed in a triangle? That means the circle touches the triangle at just one point on each side. Okay. Whereas this is called the inscribed. This is called the whatever is this is inscribed. Okay, when I talk about the triangle, I'll say circumscribed. Any questions? Any questions? Triangle, you say circumscribed because it goes around, right? Whereas the circle touches one point on each of the sides, right? So this radius is there, right? This radius is the in radius. This is called in radius. Any questions on this? But before I get into this, right, I really want you all to understand the different. Let me come back to this problem. Okay, we'll do the same way he has solved. I really like that. Okay, first let me tell you about the special segments of a triangle. What are the special segments of a triangle? Let's consider that. We will do the. We will do. I did not introduce you properly to that. I feel now. In a triangle, I'm going to go ahead and draw the perpendicular bisectors for each side. Do you understand what are perpendicular bisectors? Shaurya, are you able to understand what is perpendicular bisector? Meaning a line that cuts each side equally into two. And then, yeah, and then that line is perpendicular to each side. Am I making sense?
Yeah.
So if this is drawn to all the three sides, these are called perpendicular bisectors. Any questions on that? Okay. The meeting point. Karthik, are you there, Karthik?
Yeah.
Okay. So you know about the special segments of a triangle, Karthik, perpendicular bisectors, median, centroid, all that stuff.
Mm-hmm.
Okay, good. Working out some other problem here. So that needed edge. So we are working on that. Okay. So now the meeting point of the perpendicular bisectors is called what, Karthik? Meeting point of the huh? What is the meeting point of the perpendicular bisectors?
Won't that be like point?
Yeah, point ma. But do you know what is that point called?
No.
Okay. When you say
Centroid?
no. I'll go ahead. Okay. A medians is the centroid. Okay. Now it's very nice to see something here. Okay. When I draw with this as my radius, see, I drew the perpendicular bisectors. Okay. With this as my radius, see what I'm doing. With this as my radius, I draw the circle. It's amazing to see that this becomes the radii of the circle. Okay. When you look at this diagram, right, the circle is circumscribed. I told you whatever is outside is circumscribed, whatever is inside is inscribed, right? Or I can say the triangle is inscribed within the circle, right? Inscribed within the circle, right? So now the point of concurrency means meeting point of the perpendicular bisectors is called circumcenter. Why it is called the circumcenter? Because you are able to circumscribe a circle around the triangle. So, what did I do first? I talked about perpendicular bisectors. I drew the perpendicular bisectors for each side. I saw that they met at a point. That point was the point of concurrency of the perpendicular bisectors of all the sides of the triangle. Okay. Then what did I do? I drew the radii to each of the vertices. Then with that as radius, I was able to circumscribe a circle around the triangle. So the point of concurrency of the perpendicular bisectors, I can call it as the circumcenter. Any questions?
No.
Randy?
Yeah.
Why is like the formula for the radius of an incenter like the area over the semi-perimeter?
There's a proof. We'll see. Huh? I don't know whether I can cover the proof. Let me see. Let me see. For this one as well, right? Area will be, I think it's ABC by 4R, right? If R is the circumradius, right? Then ABC is the sides of the triangle. ABC represents the sides of the triangle. The triangle area here would be equal to ABC by 4R.
Wait, Priyanti, some of it is like hidden.
Oh my God. Okay, wait. Thing is, if I delete it, you know what would happen? Everything will go. Hold on.
Yeah,
Okay, wait. No, no, no. No, no, no. I'll do it again. Share notes. L- Um, you see it?
Yeah.
Okay. So you want to know the proof of this? Oh, that's a good one to do actually. Hmm. Okay. Now let's see. Like this, I want to go ahead with the other basic concepts and then we'll come to the proof. Okay. Now take your area as ABC represents the sides of the triangle, R represents the circumradius, area of this triangle will be equal to ABC by 4R. Okay. Did we discuss Heron's formula? Given the sides of a triangle, how to calculate the area of a triangle? Did we discuss that last week? I'll come back, Ma. If possible, we'll prove these. But then, did I talk to you about Heron's formula to find the area of a triangle given the sides of a triangle? Yes, no. Please, guys, tell me. I really don't remember. I have to check. That's why I'm asking you. Hmm?
No.
No? Oh my God. Okay. Okay. How many of you have dealt with trig? You have not dealt with trig, right, guys?
I've done it a bit like for
Done
school.
it a bit. Karthik, have you dealt with trig?
No.
Okay. Go ahead. Okay,
No.
no problem. We don't need to use trig right now. Okay, because if you ask me to prove it, I can prove it using the law of sines. But let me see. Okay, let's go ahead. Let's not prove it. Let's go ahead and learn it first. Okay, now let me erase this. So you understood. I will come back to it and ask you questions, guys. Perpendicular bisectors, point of concurrency is called the circumcenter. These are basic concepts that you have to memorize the names. The point of concurrency of the perpendicular bisectors is called the circumcenter. Why? Because you're able to circumscribe a circle around the triangle. Triangle sides are ABC. Then the area of the triangle is given by ABC by 4R. Can I move on? R is the circumradius. This one for now we are going to have it. Let's see. Can we move on? Yeah, it is. It is possible
Yes.
to. Let me see. Okay, if possible, we'll discuss proof. Okay, otherwise, I'm not going to discuss proof. We'll discuss proof again. Okay, now I'm going to talk about first we discussed circumcenter. We discussed perpendicular bisectors, circumcenter. Perpendicular bisectors we discussed. Then related to that we discussed circumcenter. That's the point of concurrency. Then we also discussed area of that triangle would be equal to ABC by 4R. This is what we discussed, right? Let that be aside. Now and there's another triangle. I said special segments in a triangle, right? Let's talk about the median. You know what a median is? Uh,
Wait, what?
Or what a median is? Median,
Yeah.
It's like it divides the other
yeah,
aside into.
yeah. So this is the segment from the vertex to the opposite base. However, it divides the opposite base into equal parts. Like, remember, if I talk about median, think of the road median. What does the median do? It's right smack in the middle, right? So that's what it does. Okay. But before I do this, guys, I really want you to know about Sevians. Okay, maybe people pronounce it differently. This is my pronunciation, guys. Okay, Sevians. Okay, so here one thing you need to understand is what are Sevians? Sevians are lines that are drawn from the vertex to the opposite base. Okay, so basically angle bisectors, medians. Median is one drawn from the vertex to the opposite base such that it cuts the base into two equal parts, right? So medians, angle bisectors are all special Sevians of a triangle. Can I move on? See, these are just words that you need to correlate with geometry, first of all, before even going into the formula. Can I move on? Okay, now I have drawn the medians, right? I've drawn the median. AB is the median of side CD, then CE is the median of side AD, and DF is the median of side AC. Any questions, guys?
No.
You see the marking? The marking shows what are the equal sides. Okay. With this in place, right? What is the meeting point of the median? Again, that's called the point of concurrency of the medians. Can I go ahead?
Yeah.
Okay. The point of concurrency of the medians, you know what is it called? Centroid. Median centroid. Like that only I remember because medians is in the middle of the road. Center is also the middle. So centroid. Okay. So now that is one. Okay. Then one another thing you need to understand here is this divide by this. What is that? The centroid cuts the centroid is at a place on the median such that the median is divided in the ratio 2:1. Makes sense, guys? Does that make sense? Meaning the centroid, which is the point of concurrency of all the three medians of the triangle, that is always at a point where it is 2:1, meaning the ratio is 2:1, meaning the length of this line segment, if you take it as three parts, then the two parts are from the median to the centroid and the centroid to the base is just one part. Okay, I know I'm telling just the formulas, right? For now, yes, to solve problems, but we need to be able to prove some of them at least. Shall I go ahead? So what did we understand? Again, a review. I drew the perpendicular bisectors. I was able to draw a circumcircle, meaning a circle around the triangle. So we called the point of concurrency of the perpendicular bisectors as circumcenter. Then we also said the area of such a triangle is equal to ABC by 4R. R was the radius of the circle and ABC were the sides of the triangle, number one. Number two, we drew a triangle. Then I drew the medians. Medians intersected. All the medians intersected at a particular point. The point of concurrency of the medians, we called it as the centroid. Now, the centroid, right, was placed on the median at a point that is two times the distance from vertex to the centroid, meaning two times of the distance, or other way of telling it is the ratio with which the centroid cuts the median is 2x is to 3x between the vertices, between one vertex and the point on the base. Okay, now we also discussed the term sevians. Sevians can be medians, angle bisectors. Angle bisectors and medians are two different or special types of sevians. Can I move on? There are a few more I'm going to discuss, okay? You should not get confused, but let's come back and review as well. Okay, now let me go to angle bisectors. You know what are angle bisectors? What are angle bisectors? The line cuts the angle into two equal halves.
Yeah.
Yep. Did you get it?
Yeah.
Now, this is interesting. Okay. Now, this is the point of concurrency of the angle bisectors. Okay. Maximum, they can ask only these four guys. Okay. That's why I'm going over them and it's quite important. Okay. The point of concurrency of the angle bisector. What is this called? Okay, before I go and name the point of concurrency, right? It's so interesting to see. I drew only the angle bisectors. Why did I draw this one? Okay. Angle bisectors. Okay. Hmm. Okay. I had to draw the angle bisectors like that. That's fine. So Now, one thing what I can do is here, see this, and this, they'll be equal basically. You know what? I'll be able to draw a circle like this in the sense these become the radius. Okay. Since I'm able to inscribe a circle, when I draw the angle bisectors, I'll be able to inscribe a circle. This is the circumscribed triangle. Any question? Circumscribed. Now, since the circle is inscribed, the radius is always represented by a small r. Okay, that radius is called the in radius. So, what would the point be called? What would be the point of concurrency? In center. That was the circumcenter because I was able to circumscribe a triangle, circumscribe a circle around the triangle. Here, I'm able to inscribe a circle within the triangle, so it is called the in center in case of angle bisectors. Any questions? Here is where Vidyut used the formula area equal to in radius times semi-perimeter. Okay, what is the semi-perimeter? Semi-perimeter is half of the perimeter of the triangle. Make sense? Okay, in that case, how to define the semi-perimeter? We said ABC are the sides of the triangle, right? Semi-perimeter is what? Who can tell me the semi-perimeter? What is called the semi-perimeter?
Half
ABC
of
represents,
the perimeter.
what is it, ma?
Half of the perimeter.
Yep, A plus B plus C by 2. Got it?
Yep.
So, you wanted a proof for this, huh? Let me see if I can do. But let me also talk about the other. What did we talk about? Centroid we talked about. We talked about there are four actually to learn. So I'll go ahead and note down the formulas anyway you'll require, but we'll come back to the proofs a little later. Or first we'll
Andy,
work out the problems and then do. Yes, ma'am.
can I go to the bathroom really quick?
Yes, you can go and quickly. Mm-hmm. Let me go ahead and do the last one. Have you heard of altitude? What is an altitude? That is the last, um, last CVN, special CVN that we will talk about. What is it? Altitude.
Like, what might be inconvenient for them? That's
Is it? 1 second. What is an altitude, guys? Come on, guess.
Like kind of height.
Kind of height, yes. So it's always perpendicular to the base, right? I don't want to draw a nice triangle. If I draw a nice triangle, you'll always think differently. Okay, I'll draw a bad triangle. So altitude is perpendicular. See, altitude cannot become the median. Median cannot become the angle bisector. Angle bisector cannot become the perpendicular bisector. Think about it. Okay, all the four are very different. Okay, so this one is. Any questions, guys? These are altitudes. So what is the point of concurrency of the altitudes? What is the point of concurrency of the altitudes?
orthocenter.
Orthocenter. Good job. Okay. Now, can I give you homework? It's very interesting. Okay. Have you heard of, you can use GeoGebra. Okay. Have you heard of this website? Karthik, have
Yeah.
you heard of this website?
No.
Okay.
Yeah.
I really want you all to go to this website. Spend some time, guys. Okay. Figure out. Okay. These are, oh, today I will tell, but tomorrow you'll forget. Okay. But once you figure out by yourself, right, you will never forget for your life. So, what you can do, go to GeoGebra, draw an acute triangle. I'm sorry. Acute triangle. Draw an obtuse triangle. It's very interesting. Okay. Obtuse triangle. Draw a right triangle. Okay. Okay, so this is a very nice thing. You learn by yourself. I don't need to tell you. Okay, draw these. Now, Draw all the four things, whatever we discussed, meaning draw the perpendicular bisectors, see the point of concurrency. Draw the angle bisectors, see the point of concurrency. Perpendicular bisectors, you'll have the circumcenter. Angle bisectors, you'll have the incenter. Similarly, draw the medians, see where the centroid comes. Draw the altitudes, see where the orthocenter comes. Repeat the same thing for an obtuse triangle. Then repeat the same thing for a right triangle. I'm telling it so simply, but this is not that simple because why? You don't know how to work in GeoGebra. Okay, let me see if I can bring it up. I don't know if I can. Let's see. GeoGebra. Oh, I'm talking on mute. Oh my God. Let me share the website with you. You can go try it out by yourself. There is uh, a tool there, okay? Meaning, first to understand the tool itself is going to take a little while. Okay, how are you going to draw a scalene triangle? Then, how are you going to draw the perpendicular bisectors? Okay, all that takes time, but I'm going to leave it to you to discuss that at home. Meaning, rather than discussing, right, sit and figure out how to draw the medians, how to draw the altitudes, how to draw the angle bisectors, how to draw the perpendicular bisectors. If you draw by yourself, then you will be, when you draw the perpendicular bisectors, you will be able to draw the circumcircle. You will be able to figure out which is the circumcenter. If you draw the angle bisectors by yourself, you will be able to find out which is the incenter, and it is amazing. You will see that you can draw the incircle as well. Okay, there is a distance tool, there is a length tool, there is a polygon tool. There are so many tools in GeoGebra that can help you do that. So I'm going to share the website alone with you. Okay, you try. Okay, did you guys get it? Did you guys get the website? Got it? So next week we'll discuss. Okay, when we meet next week, we will discuss where is the incenter, circumcenter, orthocenter, centroid for an acute triangle, obtuse triangle, right triangle. Make sense? Make sense? They are all at different locations, and some are very interesting to see where they fall in. Okay, shall we move on?
Yeah.
Okay. This is your homework. Okay, this one I can mention it and put it, but then remember what to do as well. Okay, it'll be very useful for you guys. Can I move on?
Yeah.
Okay, now let's come back to our original. Okay, so if you have angle bisectors and an incircle, right? So the area would be in radius times semi-perimeter, right? So let's go on with our problem. Okay, let's write. We want to draw, I want to go to the problem as well. So I'm going to draw the uh, circle. Let's try and see. This is the radius, right? R, R, R. I said this is A, B, C, correct? Okay. Considering that, let's see. Okay, now let me BC equal to A. We'll see how he asked me, so I cannot be without as well. Let's try to prove. Now BC equal to A, and then what? I'm going to try this out. Hold on. BC equal to A, CA equal to B, let me put it like this. CA equal to B, and then AB equal to C. Okay, we are going to try proving that, guys. Okay. We did discuss the in radius formula, right? What did we discuss? What is the formula? The area will be equal to in radius
Area
times
over.
centimeter. Yep. This is what we discussed, right? So now let's mark this out as I. Now we want to find the area of the entire triangle, right? Okay, I see. So now area will be, I see. Okay. That's so hard, guys. Okay. Okay. Now, okay, let's see this one. So basically, I think we can. So see here. So the in-center divides this entire area into 3 triangles. Am I with you or not? You all agree? Okay. Now, area. How do you represent the area of a triangle ABC? This is how you represent, guys. You should know this. This notation you should know. See the square brackets? These are just geometry concepts. Nobody is going to teach. It has to come. Okay. So ABC, this is how you represent the area of triangle ABC. So how do I represent the small triangles? Can I say BIC, BIC, CIA, and then what? BIA. Am I making sense? That's the entire area is the added value, right? Okay. How do I write the area? You tell me. What is the area of the triangles? This is easy proof. Okay. This one I don't mind proving. The other one is a little hard. The circumcenter. How do we do this? What is BIC area? BIC, BIA plus CIA, BIA, CIA, BIC, BIA, BIC. Correct. So what is the area of BIC? This is small ABC. Okay, this is B. This is A. Guys, please tell me, guys. This is just going to be perpendicular, right? Uh-huh.
Wait, why is it perpendicular?
Oh, why? Because this is a tangent to the circle. This is the radius. Okay. Okay. See here. For a circle, if you draw a tangent, right? The radius is always tangent. The radius and the tangent are always perpendicular.
Oh.
Make sense?
Mm-hmm.
Okay, then you know how to find the area of the triangle, right? What is the area of the triangle BIC? BIC. Half times A times R. This can be half times B times R. This can be half times C times R. Any questions there?
No.
Okay. Shaurya, are you following? Shivesh, are you following?
Yeah.
Okay. This is area. Now what can I do? Can I take RS common? When I take RS common, what happens? Half RS common I can take. So inside would be A plus B plus C, correct? Now I can bring that, regroup that. R times A plus B. C A plus B plus C by 2. What is that A plus B plus C by 2?
The semi-perimeter?
Yeah, R times yes. Makes sense, guys? See? Easy?
Yeah.
Mm-hmm.
But this is interesting, right? This is interesting. Can I move on? Karthik, did you follow Karthik?
Yeah.
Okay. Shall I? Okay. So this is how you get area of that. These are angle bisectors. So basically.
Hey,
Then
Priya,
this will
are
be the
they
end.
like, wait, why are they angle bisectors?
Why are the see, that is the concept of the point of concurrency of the angle bisectors is called the incenter.
Oh.
Okay.
Mm-hmm. Okay.
So this is what I want you to draw for acute, obtuse, and scalene triangles and sorry, acute, obtuse, and right triangles and C. Make sense? Okay. Now let's go back to our problem. Vidyut, now you're going to maybe explain once more. We didn't do any problems. That's sad, but then that's okay. We learned a lot. How about this? You want me to explain this, or you want to? Oh my God, what did I do? Yeah, you want to go ahead and explain once more? So this was the problem that we were doing. He used this and we were just routed. So if this is 12, this is 5. What else is given? C is a right angle, right? So by Pythagorean theorem, this is 13, right, guys?
Yeah.
Now what? What is the radius of the semicircle is asked, right? Radius, right? See, remember?
Oh, you could use similar triangles.
Yeah, you can use similar triangles too. Correct. This is R. How do you use similar triangles? See, there are multiple ways of doing this problem. Okay. So this would be 12 minus R. Correct? Correct, guys?
Yeah.
Uh-huh. How do you use similar triangles?
Uh, I'm trying to figure that out right now. 13.
Who can tell me what is the radius of the semicircle is asked? This is R, this is R. Okay. They're asking what is the radius of the semicircle. Yeah, I was also thinking, meaning I also, so they're asking for the radius of the semicircle. Okay. So, yeah, first let's go ahead with the way you did,
Oh,
okay? Let me
Priyanti,
first, yeah?
you can like make like 5 over x is equal to 13 over 12 minus
Pi,
x. Oh, I
pi
used,
over x, pi over x will be equal to pi over r. Can I take it as r?
yeah, I
Hmm.
used
Pi
equal
over r will be equal to
13 over 12 minus r.
uh, how come 13 over 12 minus r? Or 12 by 12 minus r?
Or 18, 60. Yeah, wait, Priyanti, when you solve it, you still get 10 over 3. 12,
Yeah, what did you have? 5 by r will be equal to?
13 over 12 minus r.
Which are the two similar triangles? Let's go with that.
Um, wait, can I kind
Ah,
of
yeah,
explain
you
it?
can do. Yes. You
Okay,
want me to?
so this is a right angle.
Mm-hmm.
This 13 is the hypotenuse.
Mm-hmm.
12 minus r is the hypotenuse of like the small triangle. Let's just take this as like D and E.
Nice. Okay.
So the
Let's describe
hypotenuse
what are
of
the similar triangles. Go ahead.
so like the hypotenuse of ADE is 12
A,
minus r. So
yes.
then
Okay.
and
Triangle ADE. Hypotenuse is what?
12
Yes.
minus r.
12 minus R. Good job.
And the hypotenuse of ABC is
13.
13. And you can also form a ratio with the legs. So it's
So which
like
two triangles are similar now?
ADE and ABC.
ADE. Let me try out. Okay. So you're going with the ADE. Okay. ADE and
ABC.
first hypotenuse you're covering. Okay. Correct. ABC. Good job. They are similar. So,
Wait. So then we can use the legs or something. So we can like form a proportions kind of thing,
uh-huh.
like
Hypotenuse
13
by hypotenuse. First
over
time.
12 minus r is equal
Uh-huh.
to 5, and then the r because they're both like the legs, and it's kind of like the right of the hypotenuse kind of.
Five.
So
Yes.
then 5 over r, and then
Uh-huh.
you get 60 minus 5r equals 13r, and
Beautiful.
then
Okay.
mhm.
Mm-hmm.
And then you just get 60 is equal to
18R will be equal
13r,
to 60. Uh-huh.
and then you can get 60 over 18 is equal
R
to
will be equal to 60 by 18, which is, I don't know, whatever. 3, 6 or 18, 3. 20 by 6, 10
10
by
over
3.
3.
Yeah. Okay. Shivesh, Karthik, did you follow?
Why'd you divide 18 out by 60?
Why did I divide 18 over 60? 18R equal to 60, right? What is R?
Wait, why would it be 60?
Oh, why would it be 60? Cross multiplication, proportionality,
Oh,
right? You got
yeah,
it? Okay.
yeah.
Ask. Then only it's easy. Okay. Shivesh, you feel like sleeping or okay, Shivesh? Is it okay?
Yeah.
Okay. How about you, Karthik?
It's okay.
Okay. Shall we move on to the next problem? Yeah.
Hmm?
We did very less today, guys, but we did some nice proofs. Okay. I do it in very few classes, the other one proof. Okay, let's try this. I don't have a solution in that. Let's do it. I yeah, this is a good one, but I don't. It's long since I solved. Okay, let's see this one. But I had planned for something. So, hmm, okay. Okay, do you know how to do this one? Just think about ways because these are this is the level of geometry that comes in. This is an AM8 problem actually. Can you do this one on the? Can you do this one? Can you think about how to do this one? This
Okay.
is the level that would come for AMC8. Okay, sometimes they can ask inside. They do. They have done. You can tell me, guys. Anybody who has some thought can tell me. Does not have to be right. I don't want to say the answer and get you done.
Priyanti, is the answer 6?
Oh, that I I have to check. I don't know. Okay, hold on.
Wait. What?
Let me see. I had written down the answers. Ooh. Any thoughts? Any thoughts? Please start with your what was your answer with it? Sorry, what was your answer? Six, huh?
It's I think.
Right. Okay, now let me get started with Karthik. You have some thoughts on this, Karthik? How to find the area? Area of the shaded part is what we want, right?
Yeah.
Yeah. How to find? What do you think? Meaning, see, figuring out is what is all going. It's going to be. So why don't we think about it? Shaurya, what do you think?
It's a times 4, right?
Times four of that pinwheel, one of the, yeah, that's true. But is it not difficult to find that shaded parts, one part area? It's hard, right?
Priyanti,
Well,
Yeah.
if I
I
could do all the triangles for one of them, then you could times it by 4.
You can make them into triangles, no doubt, but you will not be able to find the heights, right? It is just given that this is one. What?
Priyanti,
Hmm.
I found the like I subtracted all the white parts. So I did 25 minus like the wait.
Very nice. Yeah.
And
I
Here,
think
the
it's
only thing that
6
is
to be
deterring
honest.
me from finding the shaded area, Karthik, is it's very difficult to find that triangle area. You see, meaning even if I divide into two triangles, I cannot find this triangle area. So I can think of it a little out of the way. You see, why don't I find the total area? Okay, the unshaded part seems to be this
it,
triangle.
Priyanti,
This
technically you can.
you can. Okay, okay, we'll do both. Okay, let's not confuse. One thing is we can find the unshaded areas subtracted from the square area. That is a great way of doing. Okay, guys, that is one. That's an easy way. You all know how to find the area of the four triangles, four squares, and then subtract it from the bigger square. That is easy for you. You can do by yourself, correct? Now,
Yeah.
what do you
Uh,
think? How to find the triangle area? I'm listening too. Whoever wants to try, you can say.
I did it a different way, which is a bit more
Yeah, yeah,
complicated.
yeah. Go ahead, go ahead. Even if it is complex, it's a nice thing that's going to come with a different perception. Go ahead.
Uh, so I imagined each of these as like a triangle on their own.
Mm-hmm.
Uh, the length of this would be the square root of 2,
Nice.
and the length of this height of it, if that's the base, would be
Yeah.
2 times the square root of 2.
1 minute, 1 minute. I did not understand that. Hold on. That is what? What is that?
It's 2 times the square root of 2, because this is like half of the square root of 2
Correct.
plus,
This is the half of square root of 2
no,
plus square root of
because
2.
I'm
Oh,
doing it
yeah,
like
yeah, yeah.
this, and then there's
Perfect.
this.
Perfect. So, so what is this?
So this is 2 times the square root of 2. So if
Good.
you
Nice.
multiply those, you get 4, and divide it by 2, you get 2. But you have to subtract this area, which
I
is
really like it. Mm.
1/2.
Uh-huh.
So that's 1.5 times
Uh-huh.
4 is 6.
Very nice. Very nice. Okay. Okay. Should I repeat or are we clear with that? Karthik, Shaurya, you have to tell me. Vidyut, you have to tell me.
Miss Priya, I got 8.
8. I think it's 6 somehow. How did you get? Okay, Shaurya, go ahead and explain. Let's see.
So, can I use the pen?
Yeah, yeah, you can use anything. Just the four of you, you can draw it on the board and show.
Oh,
You can come
I
up with
thought
different. Uh,
so. I multiplied this
huh?
side by the height, and since this side is 3, that means that the height is 2.5. So I multiplied both of them,
Correct.
and I got 7.5 divided by 2, which needs to be 3 point, which needs to be 3. Wait, give me 1 sec. I think I did it wrong.
It's 15/4, I think.
Is it like
Yeah, and 15/4 is 3.75.
Mm-hmm.
Yeah.
oh
And then you
Mm-hmm.
multiply that by 4, and then
Mm-hmm.
you subtract, which gets 15. So 25 minus 15 minus the 4 squares in the corners, like this one, this
Mm-hmm.
one, this one,
Mm-hmm.
and
Mm-hmm.
this one.
That'll be a 6.
Yeah.
I
Makes
added
sense?
wrong?
Yeah, I really liked this idea. This is a great idea, Shaurya. The other idea was this, okay? Consider this as okay, pa. Consider this as your height. Find out the area of this triangle. Okay. It's easy. This one is square root of 2y because the sides are 1, 1. It's a Pythagorean theorem if you apply. This is square root of 2 and the height would be what? Height would be this is square root of 2. This is half square root of 2. Then what? Height of the triangle means it has to extend, right? So this 2 will become 1 square root of 2 and then this is another square root of 2. So the entire thing is 2 square root of 2. This is square root of 2. Then you can find the area of the triangle. Subtract this area. That's very easy, right? Half times base times height. That's only half. So from the entire area, you're going to subtract half. Then that becomes your 1 wing times 4. You'll get the same thing, 6. Any questions? Oh, that was
No.
nice, guys. I really liked discussing three different solutions. Two different solutions at least. Okay. Okay, how about this? Oh, this is a good one. Okay, why don't you solve this one? Try that one. Try that one, guys. In a non-convex quadrilateral ABCD shown below, BCD is a right angle. Let me. Okay. Please, you try. Okay, this is not a hard one. Okay, this is just spaced out of whatever we have discussed.
Did I say?
I think this is an AMC8 problem, is what I think. think. I don't know. And I had one problem written down for you guys. Let me see. I wanted to solve
I
that in
got
the class
my
today.
answer.
You got your answer? Nice.
I almost got mines.
Yeah, I
I'm
will
still
wait. No
doing
problem.
it.
No, okay, we'll wait. No pressure. Shivesh, I take your answer. Okay, I don't know. I did not calculate yet. Let's see.
Okay, I'm sending my answer. I sent my answer, Pranty.
Yeah, everybody got it. That's good. No, but I'm yet to get a couple of yours. That's okay. Yeah, I think it's right. People. Okay, in the meantime, Shivesh and Vidit, you can proceed with another problem, right? Please do. Okay, we'll wait. Okay. Let's see this one. Some easy questions you can do. Do you all know angle bisector theorem, guys?
Yeah.
Do you know, Shivesh?
No.
Okay,
Wait,
no.
Priyanti,
Yeah,
we did it in the geo class last week.
I know, right? Yes. That's okay. See here. This is the angle bisector theorem. See, for this as well, there is proof. Okay, I did not do the proof. Okay, maybe next week, if possible. See, if we start going into proofs, right, you cannot solve more problems. That's why I don't go into proofs. But see, in radius proof was really nice. So, like that, you have a nice proof for this one as well. Okay. So let's say this is the angle bisector. Now you know what is an angle bisector, right? That's the angle AD is the angle bisector, means in this case, in this triangle, AB by BD will be equal to AC by CD. This is the angle bisector theorem. This will be used everywhere, anywhere in geometry. Basic MC8 can even ask for angle bisector theorem. Okay, but
Wait,
they won't.
Priyanti, what's the problem then?
Oh, no, wait. I did
Oh,
not give you the second problem, please.
okay.
Yeah, I didn't want to forget this, so I brought it up. Okay, let's see. Wait. Yeah, so basically, I don't remember what I was working this out before the class. Oh, yeah. Yeah, this one, why don't you try? This one, I have the answer. I have my answer. Let's see. Okay, the Karthik and Chaurya, I'm waiting for your first answer. Yes, Karthik, tell me.
Can I go to the bathroom real quick?
Yeah, please go and come, Karthik.
Okay.
We'll do these both and I'll pick out one more maybe, or I don't know. Yeah. What did I do for this? 24. Oh, this one is easy. Why don't we do this one? This one is a lot AMC8. Okay. This one is a previous AMC8 problem. Okay. Let's try this. I know I drew the diagram by myself. I did not see the diagram that was given. So I want you to try as well. There are three problems. Okay. Once we finish this, we can be one.
Miss Priya, I don't understand the first one.
The first one. Okay. Would any one of you want to explain, Shivesh or Vidyut?
Huh? I can explain.
Okay, go ahead. How did you do? Because I did it in some other way. Your way may be different. Go ahead.
So, since this is 3 and this is 4 and it's
Mm-hmm.
a right angle, I figured that it would be 3, 4, and 5.
Mm-hmm.
It's a right triangle, so 5. And then this is 5, 12, and 13, which means that this would also be a right angle.
Mm-hmm.
So I just had to find the area of the right triangles and subtract, which was
Mm-hmm.
simple.
Mm-hmm.
So 5 times 12 is 60, divided by 2 is 30, minus
Okay. Sorry, Shivesh. Go ahead and write. I'm not going to write.
minus 3 times 4 is 12, divided by 2 is 6,
Mm-hmm.
equals 24.
Good job. Okay, so what did he do? He found out the total area minus that area, is it? That's what you did, right?
Yeah.
The total area was 30, the shaded area was 6, so he subtracted both, that became 24 square units. Can I move on?
Yeah.
Okay.
Yeah.
Now, did you want to try this one? Trisector means there is one another like this. Okay, these three are equal. That means what, guys? This one is 60. This
Yeah,
one. Uh-huh.
I'm done.
Oh, you're
I'm back.
done with that?
No, I'm back.
Oh, okay, Karthik. Do the second and the third one.
Okay.
Would be nice to get your answers, guys. This is not hard, provided you understand. Just based out of whatever concepts you discussed in geometry till now. I don't think this is an AMC8 problem. This one is and this one is. Okay, we'll finish with that. Yeah, and
Miss
again, we'll need guys to do more problems, meaning we'll do an AMC8 sometime. When you guys tell me, then we'll do. Maybe tomorrow, if you're all free, we can do. Tomorrow, are you all free at 9 ET or 9 ET is too early, huh? 10 ET, are you all free?
I don't know, Priyanti. Wait, Priyanti, I sent my answer for the second one, but I'm not sure.
Second one, I have my answer. My answer.
Oh, I have also sent it.
I had half as the answer. Two. I don't know.
How is it half though?
Compute the area of the
Because
triangle.
the
Oh, yeah.
equilateral triangle
No,
is
it
long.
cannot be half.
Yeah, it can't be half.
It can't be half. Compute the area of the triangle ABC. Okay, given that ABD area is 1. ABD
Oh, wait. My answer is
should
wrong.
be 2. It should be 2 is a possible answer though. What did I do?
Oh, my. Wait.
No. Was an intermediate answer. H is equal to 1.
Going to use the
Oh, it's the
recipe.
same height. Okay, I see. My intermediate answer was a half, but let me see here. This is H, right? Okay, now that is, so the area of this triangle is 1, right? Root 3 by 4 a square. Do you all know that the equilateral triangle area formula is root 3 by 4 a square? That is equal to 1, right, guys?
I take it as like s squared root 3 over 4.
A square root 3 over 4, okay. So the equilateral triangle's formula, then that will tell you what is A, right? Then that becomes so easy after that. But you know what I did? I did it in a different way. I didn't use equilateral triangles formula. Okay. So let me see. I got this out as x, x, x. What is the area of a triangle? When you think about it, this is 120 and these two are 60. So again, this will be x. So area of the equilateral triangle is what? Half times x is your base, right? X is your base. This is your base, right? Times your height. Okay. That will be equal to 1. So xh will be equal to 2. This is how I solved. Okay. And then the area of the smaller triangle, right? What is the area of the smaller triangle? Area of the smaller triangle, this one. What is the area of that? Again, the base is x, the height is h. So, or the area of triangle ABC is what is asked, right? So for that, how can I do? Will be equal to area of the triangle, big triangle ABC is half times base. Base, I'll consider it as 2x. Okay, times h. But xh is equal to 2. So when I substitute that, half times 2 times 2, that will be equal to 2. Shivesh is right. Okay.
I'm going
Any
to do the
question?
last one.
Huh?
I'm going to do the last one.
Yeah, sure. Shivesh, did you get the last one, Shivesh? Karthik, did you do the last one? Or you want to do, or you want to stop here, guys? The last one is pretty easy though. Can we try? I can give you the figure. Figure is given in the MCAT exam, so I don't mind giving the figure. I'll give you the figure. This is the figure given in the exam itself, so there is nothing wrong in me giving it to you. Go ahead. Just mark, you'll get this very easily. So this would be AF is equal to 2FE. 2FE. So let me consider this as X. This is 2X. Similarly, CD equal to 2D. CD equal to 2D. So Y, 2Y. Then the area of the ratio of the area of BFD. What is the area of BFD? BFD means this area, right? So that would be the full square. Full square area was what? 3x times 3y is the full area. You have to subtract. That's the full area. You have to subtract what? You have to subtract this triangle, that triangle, this triangle. So you have to subtract half xy and then half times 2y times 3x. That is this area. Half times 2y times 3x. This is also 3x, right, guys? Then you will have to subtract half times this one. What is it? 3y times 2x. 3y times 2x. Okay, now what do you do? 6xy. 6xy divided by 2, 3xy. This is 3xy, 3xy, 6xy. 6.5xy. 6.5xy is what? Half xy plus 6xy. Right? What is that? 13 by 2xy. I'm getting something crazy. Yeah, that's correct actually. Divided by, that's the area of the inner triangle divided by the whole circle. The square is what? It would be 3y times 3x, right? Yeah, so that should be easy. 9 9 are 18 minus 13. 18 minus 13 is 18 minus 13 is 5. 5 xy by 2 divided by 9xy. That will be equal to, I'm getting 5 by 18. What did you all get?
I also got 5 by 18.
Okay. Others?
I was in the restroom, so I don't really know.
No worries. But do you understand how to calculate? They're asking for the ratio of the area of BFD to ABCE. BFD is this. ABC is the whole square.
What is x in this case?
X in this case is this side. Because they've given the ratio, I took this as x, I took this as 2x. I took this as y, I took this as 2y.
Wait, doesn't that mean they're the same?
No, because it's a square, right? Yes, you can make it equal as well. Yes, I didn't see it's a square. Even otherwise, you get the answer, right? Because they are equal. To start with, I don't know, Shivesh, whether they are equal. That's why I took it as y, 2y. Because nobody told you that this and this are equal. You see what I mean?
But if
But
it's
I do know that 3x equal to 3y because it's a square. So x equal to y. Yeah.
yeah.
Yeah. I get it. I get it.
I think I found a different way to do it.
How, Karthik? Go ahead. Go ahead and explain, Karthik.
You know how the sides are 3x?
Uh-huh.
Wait,
Yeah. Sides are 3x. It's nice to discuss
and
ideas.
this would be 1x times 1x, so it would be less than 1.
Correct.
So then we'll so 3x times 3x would be 9. Well, 3 times
9x.
3 was 9.
Mm-hmm.
But since there's a half, we'll times it by 2, so that way it'll be easier to make, right? So it'll turn into 18.
Mm-hmm.
Okay? And then since this is 2 and this is 3, we'll times it, 2 is 6.
Mm-hmm.
And we'll do the same on the other side.
6.
Now before, since we times it again since we turned into 18, this would turn into 1. 6 plus 1, 13.
Nice.
18 minus 13 equals 5. So 5 over 18.
18. Good job. Good job, Karthik. Good way. Very
Because
nicely
I
done.
guys thought after you told me how to do it.
That's okay, right? But you thought it differently. Nice.
I,
Shall we stop here?
yeah.
Yeah. Can we meet on Friday? Okay, Shaurya is going to confirm. I will wait, no problem. Otherwise, we'll meet on Thursday. Okay, I just want to finish up with that. Okay, really, at least triangle pieces or circle related problems you should be able to do in AMC. That was the target. Okay, and I'll also finish with some combinatorics and planning. Otherwise, I'll continue geometry and at least do more geometry. Okay, next class. Any questions?
No.
But please do the GeoGebra work. Okay, if I do all that in class, class will go. I won't have time. That's why I'm giving it to you home. You can figure out GeoGebra. Okay, anybody can figure out. Okay, any questions? Okay, guys. Bye bye. We'll see
Bye,
you either on
Priyanti.
Thursday or Friday. Bye, guys.
Bye.
Bye.
Nice class, guys. Bye.